Hi everyone. This is lesson 23 on 3 ways to name a quadratic relation or a parabola. And those 3 ways we've been talking about are vertex form, intercept form, and standard form. Okay? So our first example says for the quadratic relation shown in the graph, state its equation in all 3 forms: vertex form, intercept form, and standard form. So first of all, let's see what information we can get from the graph. So we can see that we know it's vertex. So I'm going to record that over here. So the vertex is at, here's 0, 0, so 1, 8. So because we know the vertex, we know H and K. All right. And then from our vertex, we can see that they show us this point here. So that means from the vertex, we go over 1 down 2, which makes our A value -2. And then you can also see they point out the x-intercepts. So we also know R1 is, here's 0, so -1. And R2 is 3. So that's a lot of information. I'm going to start off with vertex form. So basically when you're finding the equation, if you're given all these values like we are, it's pretty straightforward to find vertex form and intercept form just by substituting into the general formula for each. So the general formula again for vertex form is y equals a times x minus h squared plus k. And we know a, h, and k, so we can substitute them in. So a is -2, parabola is opening downwards, bracket, x, h is 1, so -1, remember the minus in the formula, -1 squared, that's what makes it a parabola, and k is +8, so +8. So that's all we had to do in order to get the equation in vertex form. So there it is right there. It's our equation in vertex form. Intercept form is going to be similar. We want to know the general formula for intercept form, which is y equals a, bracket, x minus r1 times x minus r2. Okay, intercept 1 and intercept 2, that's what r1 and r2 stand for. So again, a is -2. X minus, so we've got R1 being -1, and X minus R2 is 3. And that's not simplified because we have minus a negative in here, so we're going to need to, X subtract -1 is actually X plus 1. And now we've got it nicely in intercept form. So our intercept form is going to be there. And then for standard form, we have to actually do some calculations. I'm just going to remind you, standard form has the format y equals ax squared plus bx plus c. And what we can do is we can either take the vertex form, expand it out, and simplify it, or we can take the intercept form and expand it out and simplify it. And so what I do, if there is an intercept form, I always feel like that's the easier choice. So I'm going to start off with my intercept form. And then I'm going to leave the -2 out front for now and use FOIL to multiply these two binomials together. So the first's x times x is x squared. The outside's x times -3 is -3x. The inside's 1 times x is +1x, or just +x. And last, +1 times -3 is -3. And then you get like terms there in the middle that you can collect. So -3x plus 1x is negative 2x. Oops. Still have minus 3. And then we can distribute the negative 2 through each term in the bracket. And we'll end up getting y equals negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times negative 3 is positive 6. Okay, so then we have our equation in standard form as well. So we've got all three forms, vertex form, intercept form, and standard form. So that's three different names for that parabola, and they all result in the same parabola. Okay, just three different ways to name it. So that's kind of the most straightforward example you could get, is when you're given so much information. You're given the vertex, you're given a point to figure out the a value without doing any calculations, and you're given the points for the x-intercepts as well. Then it's pretty straightforward as long as you know the general forms. So I would suggest have the general forms written out somewhere for you to refer to and use them. Okay, so the next question, or the next example, for the quadratic relation shown in the graph, state its equation in all three forms: vertex form, intercept form, and standard form. So in this case, again, we want to see what it is that we're given. So you can see that we're given the vertex. So let's figure out what that is. So here's 0. So negative 3 is the x value for the vertex. And then you can see if you read across, negative 10 is the y value for the vertex. So we do know h and k. And they're also giving us the x-intercepts. So R1 is negative 1, 2, 3, 4, 5, 6, 7, 8. And R2 is 2. But unlike the last question, we're not given a point to easily figure out the a value. You might say, well, I'm going to guess it's a half. If it was, then you'd be go over 1, up a half, over 1, up 1.5, which would put you here, but it's not. So that means that we have to use the information on how to find the a value, okay? And we can either find the a value using vertex form or intercept form. We have enough information because we have both intercepts and the vertex. So I think I'll do it using intercept form. So if I have the general formula for intercept form, it looks like this. And if I substitute in the x-intercepts, I would be substituting in R1 to be negative 8, so I'd have minus negative 8, which hopefully you're getting comfortable with, would actually make x plus 8. And then x minus 2. So you can see we've got most of the intercept form there, but we don't know the a value, and that's what we want to find. So we need another point that we know that is on this parabola, and we happen to have it. It's the vertex. So we can use the vertex right here as a point that we know is on the parabola as our x and y. And if we substitute in negative 10 for the y value, and then in both of these locations, substitute in negative 3 for the x value, our only unknown will be the a value, which we need for all three forms, okay? So we get negative 10 equals a times positive 5 times negative 5. Negative 10 equals, so positive 5 times negative 5 is negative 25, and negative 25 times a is negative 25a. And it's a that we want to get by itself, so we're going to divide both sides by negative 25. So we're going to end up getting a is, so here's a fraction. You could change it to a decimal if you want. You could also leave it as a fraction in lowest terms. You should know that a negative divided by a negative is a positive. And if I divide the top by 5, I get 2. And if I divide the bottom by 5, I get 5. So A is 2/5. So you could either have A is 2/5, or you could say A is 0.4. So 2 divided by 5 is 0.4. All right, so there's your A value. So now that you've calculated the A value, you actually have all the same things that you had in the first question. We know the vertex H and K, both x-intercepts, and now we know the A value as well. So we can write out our 3 forms. I'm going to start with intercept form since we have it almost done anyways. So we know it follows this general format. And then we can just substitute in, now we know the value of A. It makes sense for it to be positive, and it makes sense for it to be smaller than a half. Okay, so 2.4 is smaller than 0.5. I could have put 0.4 here, 0.4, because it's exact. That would have been fine as well. And then x minus R1, so we did that up here. It turned out to be x minus -8 or x plus 8. And x minus 2. So there's our intercept form. Vertex form. Come up here to do vertex form. So again, the general formula for vertex form is y equals a x minus h squared plus k. And we need to replace a with 2/5 or 0.4. And then our h is -3, so that's going to be x minus -3. But we know that that's going to make x plus 3 squared. And then k is -10 minus 10. So there's our vertex form. And then we need to get our standard form. So I'm going to take the intercept form and then multiply it through. So here's where I might prefer to use 0.4 because it might be easier to multiply through. I'm going to show it with the 2/5 just because I don't want people to be afraid of fractions. But if you want to put the 0.4 there, you would be able to do that. And because it's exact, you wouldn't lose any marks. Okay, so again, when you use intercept form to turn it into standard form, you want to multiply the 2 brackets together using FOIL first. So that's going to give me x squared minus 2x plus 8x minus 16. And then I'm going to collect the -2x and the plus 8x, which gives me plus 6x. Minus 16. And then you have to distribute the 2/5, and that's why some people might rather use the 0.4 through all 3 terms there. So 2/5 times x squared is just 2/5 x squared. 2/5 times 6x, so treat it as 6x over 1 and multiply the tops together. So that's going to be plus 12x, and then multiply the bottoms together over 5. Oops, I'm running out of room there. And then multiplying 2/5 by -16, you want to treat that as multiplying the tops together. So 2 times -16 is -32. 5 times 1 is 5. And then I would probably check and see if any of those fractions reduced. They don't. So that's my standard form. And I've stated the equation of that parabola in all 3 forms. Okay, the next example, example 3. Given the parabola y equals -2 times x plus 5 times x plus 8, make a graph of the parabola showing any relevant calculations. So we're coming back to yesterday. We should be able to look at this intercept form here and determine that our A value is -2. R1 is -5, because remember the general formula for intercept form has a minus in the formula. So for you to see a plus inside the bracket means that it must have been subtract a negative. Okay, so R1 must be -5. And then same thing, we have a plus in this bracket as well. So R2 must be -8. So again, like we did yesterday, if we know the x-intercepts, we can plot them on our graph. So -1, 2, 3, 4, 5, 6, 7, 8. There's our two x-intercepts. And then if you also remember from yesterday, to find the vertex, you use the formula. To find the h coordinate of the vertex, you use the formula. H is R1 plus R2 over 2. So that's -5 plus -8 over 2, -13 over 2, which is -6.5. Okay, so that means that that's 6.5, somewhere along this axis of symmetry is going to be our vertex. So then we want to find the k value. So to find k, we use this formula here. Replace y with k, and then replace each x with -6.5, because we want to know the y value that goes with x being -6.5. And also this one, so -6.5 plus 8. Then just do the calculation. So -6.5 plus 5 is -1.5. And -6.5 plus 8. -6.5 plus 8 is 1.5. And then we can multiply those three numbers together. Sorry. So we're going to do -2 times -1.5 times 1.5, and that gives us 4.5. So now if we put those together, we get the vertex to be -6.5 and +4.5. So then we're going to plot that on our graph. -1, 2, 3, 4, 5, 6.5. +1, 2, 3, 4.5. So right in the center of this square here is our vertex. We also know that our step number is -2, which means that our step pattern is going to be down 2, 6, 10. So from our vertex, we're going to go over 1, which still puts us in the middle of the square, and down 2, so we're in the middle of this square here. And then same thing, over 1, which puts us in the middle, down 2. Our next step is over 1, down 1, 2, 3, 4, 5, 6, so into the middle of this square. And same thing over here, over 1, down 1, 2, 3, 4, 5, 6. And then our next step would be over 1, down 10, but you can tell that that's not going to fit onto our graph. So once you've got those points, you want to join them with a smooth curve, and they should look like they go through the x-intercepts when you sketch your graph, and they do. Okay, so first part of the question was to make a graph of the parabola showing any relevant calculations, so we did that. Part B, determine the equation of the parabola in vertex form and in standard form. Okay, so they gave us the equation in intercept form. Now we have to find out the other two forms. So we'll start off with vertex form. So the general equation for vertex form is y equals a x minus h squared plus k. And this is our h, and that's our k. And we know a is going to be the same for all of them. It's going to be -2 way up here at the start. So a is still going to be -2. And then we have x minus negative 6.5, that's going to become x plus 6.5 squared plus 4.5. So there's our vertex form done. Okay. To get standard form, I'm going to start off with the intercept form that they gave us. So y equals negative 2 times x plus 5 times x plus 8. And then I'm going to expand and simplify, and that will give me the standard form. So if I use FOIL here, x times x is x squared, x times positive 8 is positive 8x, 5 times x is positive 5x, and 5 times 8 is positive 40. And that's going to give me plus 13x plus 40. And then finally I have to distribute the negative 2 through each term in the bracket, giving me y is negative 2x squared minus 26x, negative 2 times positive 13x, minus 80. So there is my standard form, the form y equals ax squared plus bx plus c. Okay, all right, so that's our third example. Our fourth example, given the parabola y equals a half x minus 3 squared minus 2, make a graph of the parabola showing any relevant thinking. So you would want to realize that this is given to us in vertex form. So my relevant thinking would be that, I can tell the vertex is hk, so 3, negative 2, because it's in vertex form. And I also know the step number a is 1/2, and it's positive, so that means my step pattern is going to be up 0.5, 1.5, 2.5, etc. Okay, so that's my relevant thinking. Now I'm going to do it. So I'm going to plot the vertex at positive 3, negative 2, and then follow my step pattern. So over 1 up 0.5 on both sides, over 1 up 1.5 on both sides, over 1 up 2.5 on both sides, over 1 up 1, 2, 3.5 on both sides, and 4.5 doesn't fit, so then I'm just going to draw it in using my best smooth curve there, arrows on the ends. So there's A done. And then part B, determine the equation of the parabola in intercept form and standard form. So while we were drawing it, we revealed what the x-intercepts were. So there's one of them at 1, and then, because here's 0, 1, 2, 3, 4. Here's the other one at 5. So we just determined for intercept form that R1 turned out to be positive 1, and R2 turned out to be positive 5. So intercept form should be pretty easy to find. We're just going to use the general formula for it and substitute our values right in, because that one worked out really nicely that we found the intercepts while we were drawing the vertex form. So our A value is going to stay the same at a half, x minus 1, because R1 is 1, x minus 5, because R2 is 5. So there is our intercept form. And we still have to find our standard form. So to get the standard form again, I'm going to start off with the intercept form and then expand using FOIL. So x times x is x squared, x times negative 5 is negative 5x, negative 1 times x is negative x, negative 1 times negative 5 is positive 5. And then I can collect the middle terms. Negative 5x minus x is negative 6x. And then plus 5. And then I have to distribute the half to each of those. So a half times x squared is a half x squared. A half times negative 6x, you can think of it as minus 6x if you multiply the tops together, over 2 times 1 is 2. And then you can also think of that as multiplying the tops together, so plus 1 times 5 is 5, over 2 times 1 is 2. But you always want to check if the fractions can be reduced, and in the case of negative 6 over 2 or negative 6x over 2, 6 divided by 2 is 3, so that just gives me minus 3x plus 5 over 2. So that would be my reduced standard form. Again, you could have used 0.5 if you're more comfortable using the decimal. Okay, so then we've done that one in all 3 forms as well. They gave us the vertex form, we drew it, we figured out the intercept form, and then we figured out the standard form. And just wanted to point out, in standard form, the C value is the y-intercept. So a good way to check and see if you're right is check and see if that is the y-intercept. So 5 over 2, which is the same as 2.5, should look like your y-intercept. So you can see here's the y-axis, and it does hit right at 2.5. So that's a good check to make sure that you're right. Okay, our next question. Determine the equation of the parabola in vertex form by first calculating the A, determine the equation in standard form, and also explain why this parabola cannot be written in intercept form. Okay, so first we always want to look at what information we're given. So we're given the vertex, so I'm going to figure out what its coordinates are and write it down. So negative 1, 2, 3 for x, and negative 1 for the y value. So those are our h and our k. And we're also given that there's a point on our parabola that has the coordinates 2, negative 6. So because I'm given the vertex, and you can also even see there aren't any x-intercepts, I'm going to use the vertex form. So the general vertex form is y equals a times x minus h squared plus k. And by knowing the vertex, I can fill in h and k. So that's going to be x minus negative 3, which is x plus 3 squared minus 1. So I don't know a. This is where this point comes in. I know that the point is on the parabola, so we know that for this parabola, when x is 2, y is negative 6. So I can replace y with negative 6 and replace x with 2, and then a becomes my only unknown value. So 2 plus 3 is 5, 5 squared is 25. So a times 25 is 25a. And now I have a fairly straightforward equation to solve for a. So I'm going to add 1 to both sides, creating a 0 pair there. Negative 6 plus 1 is negative 5. And it's a we want to get by itself, so we're going to divide both sides by 25. And a is negative 5 over 25. Which reduces to negative 1/5. Okay, so negative makes sense. 1/5, you can see you go over 1 down not very much, so the 1/5 makes sense as well. So there's our a value. So let's remember what the question's asking. Determine the equation of the parabola in vertex form by first calculating the a. So now we could come back over and state our equation in vertex form. So we now know a is negative 1/5. And we can put our h and k back in. And there's our formula in vertex form. So the vertex form is right here, completed now with a, h, and k all substituted in. Okay. We also have to find the standard form. So since there's no intercept form, we have to expand the vertex form in order to put it into standard form. We haven't done one like this, so it's good to practice that. So to square this binomial, or to expand x plus 3 squared, we're going to write the x plus 3 out twice, and then we still have this minus 1. And then I'm going to do the FOIL, so I'm going to leave the negative 1/5 out front and multiply the x plus 3 by x plus 3. So x squared plus 3x plus another 3x plus 9, close my bracket, minus 1. I can collect these like terms. So now, before I can subtract 1, I have to follow BEDMAS here. I have to multiply. And you have to multiply using the distributive property. So negative 1/5 times x squared is negative 1/5 x squared. Remember, I can think of that as plus 6x over 1. So that's going to give me negative 1 times positive 6x is negative 6x over 5 times 1. And then I can think of positive 9 as positive 9 over 1. Negative 1 times 9 is negative 9 over 5 minus 1. But now these are like terms. So you have a fraction and you're subtracting a whole number, so you would need to get a common denominator with those last two terms. And that common denominator would be 5. So I can rewrite minus 1 as minus 5/5. 5 divided by 5 is 1. And then I can collect those terms. Negative 9/5 minus 5 more fifths is negative 14/5. So there is our answer in standard form. All right, and our last example for the quadratic relation shown in, oh wait, sorry, we forgot to say why there isn't a vertex form, or sorry, an intercept form. So explain why this parabola cannot be written in intercept form. So this parabola cannot be written in intercept form because it never touches the x-axis, which means it doesn't have any x-intercepts, okay? So it starts, the vertex is below the x-axis and it goes downward, so it's never gonna touch the x-axis, okay? And if it doesn't have any x-intercepts, it can't have an intercept form. So make sure you understand that reasoning, why there isn't an intercept form. We did talk about that before, so all parabolas have a vertex form and a standard form, but only ones that have x-intercepts have an intercept form. Okay, so our last example. For the quadratic relation shown in the graph, state its equation in all three forms. Okay, so this time you can see we're given the x-intercepts. So R1 is negative 1, 2, 3, so negative 3. R2 is positive 2. We don't know the vertex. It looks like it might be at negative 0.5 for the h, but we're not going to guess. But we do know this point is on the parabola, and that's the point 1, 8. So because we know the intercepts, we're going to start off with our intercept form. And fill in what we know. So we don't know the a value yet, but we do know R1 is negative 3, so x minus negative 3 is going to be x plus 3, and x minus 2. We also know this point is on the parabola, so we can replace y with 8, and we can replace x with 1. And then our only unknown value is a. So we can calculate the a value. So 4 times negative 1, so negative 4a, divide by negative 4, and it turns out that a is negative 2. And you can look and see if that makes sense. Here, when we go over 1, does it look like we go down 1, 2, and then over 1 down 1, 2, 3, 4. Wait a second. Oh, over 1's in the middle here. Down 1, 2, over 1, down 1, 2, 3, 4, 5, 6. Yep, that looks right. Okay. So there's our a value. And now we can write out our intercept form with the a value in it. So our intercept form is y equals negative 2, x plus 3 times x minus 2. So there's our intercept form. Once we know our intercepts, we can figure out our vertex using calculations. So vertex can be found by adding the intercepts together and dividing by 2, the h coordinate. So that's going to be negative 3 plus 2 divided by 2, which is going to be negative 1 divided by 2, or negative 0.5. And then k can be found by substituting into the intercept form. So I'm going to bring this, that's my y, and it's negative 2. I'm going to replace the x with negative 0.5 in each of the factors. So negative 0.5 plus 3 is 2.5. And negative 0.5 minus 2 is negative 2.5. So then when I calculate that k value out, I get negative 2 times 2.5 times negative 2.5 gives me positive 12.5. So let's see if that looks right for our vertex. So that's telling us our vertex is at negative 0.5 and positive 12.5. So rather than guessing, we calculated it. So negative 0.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5. So there's our vertex, and we calculated it out. So now we should be ready to do our vertex form. So we know our general equation for vertex form. We know this is h and k. We know a is negative 2. So that would be x minus negative 0.5, so x plus 0.5 squared plus 12.5. So that's our vertex form. And now we need our standard form. So to get the standard form, I'm going to expand the intercept form oops. So use FOIL. X times x is x squared minus 2x plus 3x minus 6. Combine the like terms, so that's plus 1x or just plus x. And then distribute the negative 2. So our standard form is y equals negative 2x squared minus 2x plus 12, because negative 2 times negative 6 is positive 12. So that's our standard form. And that's the equation of this parabola in all three forms. Okay, so we've gone through a lot of examples of how to name a parabola in three ways. We did point out in the last example that not all parabolas have all three forms. Some don't have an intercept form, so keep that in mind and try the practice.